Hi, I'm Marco De Stefano from DLR, and I will present the work on an energy-based approach for the multi-rate control of a manipulator on an actuated base. The goal of this work is to design a coordinated control strategy for a manipulator and its base. Usually for space scenario, the robotic arm is controlled at high rate and the base at low rate control. In this paper, we will see that different rate of the controller can lead to instability, and we propose a method to cope with it. First, we design the controller in continuous time. The manipulator control has a torque law using the simple Jacobian transpose. The controller of the base is a PD plus a term, which is function of the force of the manipulator. We prove the stability of this controller with the proposed Lyapunov function. In continuous time, the system results to be stable and the error of the controller converge, as you can see for the manipulator on the first row and for the base on the second row. However, when the controllers run with different sampling rate, the passivity properties are broken and the system becomes unstable, as you can see in this simulation, where the controller of the manipulator runs at 1 kHz and the controller at the base runs at 2 Hz. The interaction of the multi-rate controllers will generate an unstable behavior of the total system, as you can see now. It can be seen also in the error plot for manipulator and base, which does not converge to zero. In this work, we will address this problem. The effects of the multi-rate control are identified in the proposed network representation, where the multibody dynamics here receive from one side control force of the high rate control, the manipulator, and from the other side, control force of the low rate control, the base. We check the passivity condition with an energy observer at this port, which is function of the force acting on the base and the velocity of the base. If the passivity condition is violated, we act with a passivity controller in order to modify the input force to the multibody dynamic system and to restore the passivity. Here are some results. The energy observer detects activity in the system and the passivity controller provides the correction as input force to the multibody dynamic system. Therefore, the passivity of the system is restored and the error of the manipulator and base converge to zero for the considered control. If you have any questions, we can meet in the upcoming interactive section. Thank you for your attention.